All right, so a coding kata, the coding kata, the term kata comes from martial arts, and in martial arts, kata is a series of moves that you practice over and over again until it just becomes ingrained, and the coding kata is the same concept. You practice coding, solving some kind of coding problem or some coding process over and over again until it gets ingrained. And what we do here is TDD, or test-driven development kata, so we practice the test-driven development cycle in solving a simple problem. And the kata that I'm going to do tonight is actually one that it's solving the same problem that I solved 2 meetups ago. Yeah, there we go. It's because I haven't switched it over yet. And so what the problem, the general problem is taking low-level data in for some kind of message and framing the messages. So I'm using a real simple version called SysEx, or System Exclusive Message. It's a kind of message in that musical instruments used to talk visually to each other. And with the SysEx message, there's a particular byte that indicates the start of the message, and a particular byte that indicates the end of the message, and everything in between is the message. And the problem is, the problem is twofold. Number one, there are messages in MIDI string that are not SysEx messages, so you have to ignore those. And also, the messages don't come in one by one. Sometimes you could potentially get a part of a message and then the rest of the message, or you could get more than one message in one chunk, and you just have to be able to handle all that. So, and 2 meetups ago, I did this with a very mutable, stateful approach, and I decided I want to do this again in a purely functional approach. So that's what I'm going to do, and start guard up here. I'm running my tests. And this is going to be a little bit deceptive because it's going to seem like it's easier to do this time in the functional style, but it has just as much to do with the fact that I practiced it more. So first thing we want, we'll start writing the test. First thing we want is if there's no data, we just want our messages to return an empty array. So the data, it returns to empty array. So is that big enough for everybody to see?
Yeah.
Okay. So we expect a new object with no data. If we call messages, we just want to get an empty array. And of course that fails because we haven't implemented messages yet. So in this case, we want to change the failure message by defining messages. And now we've gone from an error to an actual failure message. Expected empty array and just got nil. So we can easily fix that by just returning the empty array. And the first one passes. All right, moving on, we want to be able to actually parse the data. So the next simplest test is probably with a single frame of data. And it turns the message in an array. So the purely functional interface to this is going to be, we have a new class, and then we give it some data. So the F0 is what indicates the beginning of the SysEx message, and we'll put some data there, and then the F7 indicates the end of it. And then call messages, and that should give us an array with 1 and 2. And once we get this to pass, we'll clean that test up a little bit so it looks nicer. But, so we got the message, failure message, no undefined method data. So we change that message by defining data. And now now we have wrong number of arguments, so we need to give it a parameter here, bytes. And now we get an interesting error message, undefined method messages. Well, the reason is because the way we're calling this, we're expecting data to return a new sysx object, and instead it's returning nil, which has no messages method, so we just return self here. And now we've got to a failure message, which is what we want. So obviously we got the empty array because that's all we're returning for messages. We need to fix this. We need to actually capture some messages somewhere, something other than just a literal. We need to generalize our class here. I'm going to make this pending for now so I can refactor sysx a little bit. You never want to refactor when you have failing tests. So I'm just going to add an initializer parameter there, and I'm just going to make this attribute reader. Get rid of that. And because I'm defaulting it to empty array when I initialize, our test should still pass, and it does. So now I can go back to making this test pass. So what I actually have to do here is actually create a new sysx that has the proper messages in it. So I can just, instead of self, return I don't want to return the whole array of bytes because that actually has the framing data which I want to pull off of there. So you need to strip that off, and one way to do that is to use a range. So what this does, since arrays are 0 indexed, 1 starts at the second element of the array, and then in Ruby, arrays are indexed with negative indexes. Start from the end of the array, so -1 is actually the end of the array, and I use 3 dots on the range to say exclude the last one, so that actually chops off 1 byte on both ends, and it passes. All right, I'm going to clean up this test a little bit. Using that, I'm just going to say, just pull this up. That. That, and so that's a little bit easier to read. All right, next, another thing that could happen is we could get a frame in 2 chunks. We could get just part of a frame and then the rest of the frame. So 2 chunks, and actually we should get the same thing back. So I'll reuse this, but I'll just break the data into 2 chunks like that. And of course that fails, which is good. We want it to fail until we write the code for it. And what's happening here is we're getting 2 messages that are both, if we strip off the first and last byte, we end up with the empty array. And interestingly, we're only getting 1 array. So what we can do to fix this, we have to actually keep track of a partial frame in between calls to data. So I'm going to add another parameter here. I'm going to call this just act for. It's easier to type than partial. So just act for, like, short for accumulated data. And what we need to do now is actually look to see if we've got that, because if we get a partial frame, we don't have that ending, that end of frame indicator, so we need to look for that. So we can say bytes, if the last value is that ending thing. sysex that just has the bytes in the accumulator position. We also need to, this is not going to work yet. What we also need to do is actually use that accumulated value. So we actually just change this to, and is that going to work? Yeah, that works. Okay. Anybody confused yet? All right, so next thing, what if we get 2 frames? So far, we've only been doing 1 frame, so let's generalize a little bit more. Let's say, just copy this. And put in another frame. And it returns 2 messages. So now we spectrum messages to have the 1 and the 2, and then the 3 and the 4. And let's see what happens. Well, we got our 3 and our 4, but we lost the 1 and the 2. So what's going on there? Well, what's going on there is we're not keeping track of, if we already have some messages, we're just kind of throwing them away. So what we need to do here is actually include the messages in the array. What we're doing here is, what that splat symbol does is it actually expands those messages as arguments to the array operator, to the array creation operator, or array literal operator. So I don't know what else to say about that, but
They're not nested.
What's that?
It's like it's not nested.
Yeah, like unnested. So, yeah, if we just did that, it would be in all our previous messages would be nested in a single array. What this does is sort of flattens it out, and that works. All right. So what if we have the other thing that can happen is we can get 2 frames at once. So 2 frames and 1 chunk. So that's just, if our data looks like that, we still want to get the exact same 2 messages. And what happens now? Uh-oh, we're getting 1 big message with the end and start frame bytes there in the message. So the problem is we're just looking at the end of our bytes instead of, we actually need to find the first end frame byte. So one way we can do that is we can say I equals bytes.index. What this does, if it finds that that byte is in our array of bytes, it'll return the index of it, otherwise it'll return nil. So that's why we can use it in an if. And then what we want, we can start by going, just doing that. See what happens. So we went from getting only the, we went from getting all of it to just getting the correct first message. But we still don't get the last message because we then need to recursively call this with the rest of the bytes. So we need bytes dot, and I think we can just drop the first I plus 1 bytes. And what did I do wrong? How I did this. I just practiced it today too. I'm actually surprised with that's what I need. I need the index of it. It's still not working. I'm calling, no, that's
Data
not right.
doesn't take messages.
Yeah, data, what am I doing wrong here?
Why do you need to use data again? Why can't you just pass it in as to the accumulator?
Oh, I could probably, because it doesn't actually break it out into the messages until data is called. So I still need to call data.
So you're passing one dot 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 I to the accumulator.
Yeah, so in this case, I is going to be 0, 1, 2, 3. So I want to drop 4 of those when I recursively call data.
But the accumulator will be contained.
What's that?
But the accumulator will contain those bytes still, right? Because you did.
Yeah, but I'm dropping all of it because I'm getting the index into the whole thing. Actually, in this case, accumulator will be empty, so it's actually irrelevant.
Looks like accumulator will be accumulator plus bytes array 1 dot 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 I.
No, that's added to the messages.
Oh.
Yeah.
Yeah, okay.
Is the index guaranteed to calculate the first occurrence until XS7?
Yeah.
If it's there, yeah.
I say use pride.
If you want to totally go down a different path, I would refactor.
I was going to suggest what you're about to do, which is subscripted I plus 1 dot dot negative 1.
Oh, yeah, I read that dot negative 1.
Right.
Or no, dot
No,
negative
dot
1.
negative 1. You need the entire rest of it. Because
That's gonna,
continuation.
that's the same result. It's the same thing. Don't do that. It's just that.
Get rid of the add ACC if you 2 lines up. Or do you really just need?
No, I need that because I don't need it for this test, but
You can always make the sys new on make that the accumulator twice as long by just adding the 2 arrays. So instead of calling dot data, you can just create like a regular. So 2 lines down from there, instead of calling dot data, you could just do like a parentheses around the first dot act.
but that's going to be in this case that's always going to be empty. So.
Well, okay, never mind.
How about throwing the put s in your initialize? Let us see what's happening.
Yeah.
All the times I practice this never happened.
It's getting into that second
Bad
branch,
range,
right? It's not finding a.
When it doesn't
It's
find
getting into that second branch of data. It's not.
Oh, right, because I'm recursively calling it, it's then calling it again with the empty array. That's what's going on. Yeah, you're right. I thought I needed another test before that. So I need to do that. All right, that worked. I thought I needed another test before I wrote that out. Okay, now I'm going to do a little bit of refaction here. Let's get rid of this magic number. All this.
When this timer runs out, we can have 5 minutes for questions.
Okay. All right.
That's where that frame stop.
Oh yeah, you're right. Frame in. That's frame in. Okay. All right, so, all right, should be able to knock the rest of this out pretty quick. So the thing we haven't considered is data that's not a sysex message, which we can get. So let's do with noise. I'm calling it noise even though it's valid data. It's just data we don't care about. So to us, it's noise. Noise in the frame. We want it to be just like the noise isn't there. So we have like noise at the beginning. What happens? It fails because it's just chopping off the first one. It's not actually looking for that frame start specifically. So there's a couple of ways we could solve this. Sort of real quick, simple. Let's see. Well, let's see. How can we solve this? Actually, normally. Well, let's refactor first. I'll solve it. So I really hate repeating this act plus bytes in here, so I'm going to do actually call this parse bytes, and I'm going to find a new data bytes that calls parse and bytes. And then we can get rid of change every so that to just bytes. All right. So now, with that refactoring, it becomes simple to sort of cheat and just say drop any byte. Let's drop while that's not equal to frame start. So this is just going to drop any of the noise before the frame start. And that works, but that's not ideal. There's a lot of problems with this. We've got the trimming, split up between these two methods. What we really need to do is actually do this index frame start and then change this I to J. Good, I did that right. And these are a little bit ugly. I'd rather say, I think take J, drop I. I don't think it's quite right, is it? Drop I plus 1. Is that right? Yeah. And then here, take J plus 1. No, drop J. Drop J plus 1. Okay, it's getting a little bit better. All right, so squeeze one more test in here. What if the noise is at the end of a frame? And I think this might actually already work. Yeah, that already works. And what if the noise is, what if we have 2 frames with noise in between? Actually, I don't know that previous one's important because it's the same thing. But a frame and noise, it actually run both tests. Okay. All right, so if we have 2 frames with noise in between, oops, oh, that's cool. Now I can check that here. 2 frames, noise in between, and okay, so well, we've got something that works pretty well. I don't have time to refactor it further, but And that's it. So questions, comments?
Yeah, so now we have 5 minutes for questions and comments.
I follow along with everything on that one.
Yeah. How many people had never seen Cajun drop used before on arrays in Ruby?
Oh, I've never seen that.
I've seen them used in general, but not
No questions or feedback? Oh.
It was good.
Yeah.
You know, I'm not as well versed as some of the other people. Why is it the I+1 for the drop? Like, why is that index I+1?
Because the arrays are 0 indexed. So if we find, or you're talking about this one right here?
Yeah, that one and the one before, yeah.
Okay, because arrays are 0 indexed because we want to, so if the index, so in the first case, we want to drop everything including the character we find. So if it's, let's just say it's the second byte in there, the index is going to be 1. If it was the first byte, the index would be 0. The second byte, it's 1, but we actually want to drop 2 to drop that one because we want to drop the thing we found as well. And the same logic applies to the same logic applies here. We want to drop everything up to and including that thing we found.
Yeah, you take the pictures.
I took one too.
Hey, question. So how do you feel about this code, this exercise versus the one 2 weeks ago? Which do you prefer, and which do you know, what are the pros and cons of each?
The simplest solution that I ended up with in the very mutable imperative style was simpler than what I ended up with here. Even though even after I can refactor this further to make it look better, but I still never got to where it was like 4 one-line methods like I could get before. So this is one of those problems that's it seems to fit the mutable imperative style a little better. That said, the first time I did this version of it, I ended up going into going down the same route where I turned it into a state pattern where I had the 2 different states, and the purely functional style ended up being a lot simpler than the mutable state pattern, which surprised me. I finally found a way to do the state pattern that I liked, and it was in a purely functional style. Did that answer your question?
Yeah, I mean, I think from 2 weeks ago, I mean, that code was just much more legible. This code seems to be much more archaic and
Yeah, I haven't, well.
Opaque is probably.
Opaque, yeah. If I could, so part of that is if you're used to programming in one style, seeing the other style is not going to, it's going to be harder to understand whichever way it goes. Purely functional programmers actually have a hard time understanding a lot of imperative code in the same way. And part of it's because I just didn't have time to fully refactor it. And it's actually not a simple problem to solve in a functional style in a readable way.
I mean,
Leo.
to convert it into a more functional style, would you then pass the like @sign messages as one of the arguments so it doesn't show up as a like an external variable?
This is a purely functional style. I mean, it's object functional, but
Oh, all right.
um,
I was thinking